Hello, this is video number 2 for Trig unit number 2, and you should have your notes packet with you. If you flip to where we left off after the first lesson, there is a blank side, blank back to the previous notes. And on that blank page, I'd like you to do the following. At the top of your blank sheet of paper, draw a 30, 60, 90 triangle and a 45, 45, 90. Label the sides with the numbers that fit the special patterns. Please hit pause, and then we're going to see if you drew it right. Okay, you should have your drawings made. Okay, don't peek until you've drawn them yourself. This is a way to test yourself. But here is my set of pictures. And these pictures could be turned or flipped around, but what you need to check for is relative positioning. So, for instance, this 30 needs to be across from this 1, no matter which way your triangle is facing. And the radical 3 needs to be across from the 60, and the 2 here should be the hypotenuse. And on the 45, 45, 90, you should have 2 sides that are equal in length, and you should have radical 2 on the hypotenuse. Okay, with those pictures, we're going to be doing a lot with these pictures today. And for the next task, you need a pair of axes. So you can continue to draw on that same piece of paper, or you can flip ahead. There's several copies of the same chart, and on the back of the first chart would actually be a good place for this as well. Okay, we're going to draw, if you look ahead, we have several charts, and we're going to put a picture that goes with each of the, we're going to have a picture that goes with each of those charts. So if you want to put the picture for each chart on the back of the chart, that would work pretty well, okay? Our first picture is going to be, again, that triangle that you drew in the warm-up, which is a 30, 60, 90 triangle. And I'm going to draw that right here, and I'm going to put in the labels for the sides, just as you did in the warm-up. Okay? Now with that triangle, what we're going to do is we're going to flip it. We're going to flip it into each of the quadrants. So imagine this triangle is like the page in a book, and you flip it over right now like you're turning the page. Then that triangle would end up over here. And all the measurements would come with it. So this vertical length would be 1, the hypotenuse would be 2. The label for the horizontal side would slightly change just because now we're going to the left with it, so it would be a negative radical 3, okay? And this angle of 30 degrees would still be 30, and so, etc., okay? Now let's imagine taking the blue triangle that I just drew and flipping it down. So it's still the same triangle. It's just oriented in a different direction. That looks a little bit jaggedy there, so let me just touch that up a bit. No, it still looks jaggedy, but we're going to go with it this time, okay? So the hypotenuse is still 2. This side, this vertical side, is going down, so I'm going to label it with a negative this time. And the interior angle there would still be 30. And now let's flip the green triangle to the right. And so now it would be over here in the 4th quadrant. And this side would still be 2, and going down is negative 1. We have 30 degrees, 60 degrees, 90 degrees. Still the same triangle, okay? Now, as I step back from my screen, I see that these don't look exactly equal in size. They're a little bit distorted just because of my lack of drawing ability. But all 4 of these triangles indeed are supposed to represent the same triangle, congruent triangles, okay? Now, if you look at the chart, I have some lines in yours that aren't here on my screen. We're going to ignore certain lines. So make sure you're aware of where the 0 degrees is, okay, just as a landmark, right? There are a whole bunch of lines in this region that's highlighted here on mine that aren't even present on my screen, okay? You have a bunch of lines that I don't have. So make sure you're aware of where we are, okay? On this chart, we're just going to be paying attention to relatives of the 30-degree angle. So the key is 30 degrees, so I'm going to highlight that line right now for myself, 30 degrees. You might want to put a little star by yours, okay? We're going to pay attention to that 30-degree line. And now look back at the picture with me so you can understand what I mean by relatives, okay? We are going to look now at all of these different triangles, like I mentioned. And what I'd like you to notice is this angle of rotation, okay? How big is that arc that I just drew in? What angle is that representing? Well, it's not quite 180, right? So about 30 degrees less than 180. So this would be a 150-degree rotation. So Relatives of the 30-degree angle would include 150. Let's see what else we can find, okay? Let's take this angle, going around to there. Well, that's 180 plus a little more, plus this little angle that's within the green triangle. So what angle would that be? You're right, it's 210, right? 180 plus 30 degrees more. And now the last one I'm going to ask you about is coming all the way around to this black triangle, okay? So that's not quite 360 because we have this 30-degree angle in here that's left over, right? So it's not quite 360, but what is it? I hope you said 330. That's correct. So the four angles that I've listed over there to the side are what I would call the relatives of the 30-degree angle. So on this first chart, those are the lines we're going to pay attention to. We're going to pay attention to 30. We are going to be filling in some information about 150. And then 210. And then 330. So those are the only four lines you need to pay attention to on this first chart, okay? Everything else is going to be extra, okay? We're just going to look at those four lines. All right, back to the picture. When we're looking at 30 degrees, we hopefully can figure out from the red triangle what sine, cosine, and tangent values are. Let's see, cosine for 30 degrees, for instance. Cosine is adjacent over hypotenuse, or x over r. That would be root 3 over 2. How about sine? Well, sine is y over r, or opposite over hypotenuse. That's a half. And tangent of 30 degrees, well, that would be y over x, or opposite over adjacent. That's 1 over root 3, but I know from rationalizing that so many times, that's root 3 over 3. So these are the values of the 30-degree angle. I could fill those in on my chart, so I think I'll do that. Root 3 over 2, 1/2, root 3 over 3. Notice the order here, okay? I'm going every other one, and cosine is actually first on this list, not sine, okay? Now go back to the picture. Okay, if I'm over in the blue triangle, what would happen to my values? Cosine, sine, tangent. But this time I'm going to say that that's 150. That's how many degrees I would have had to rotate to get to that position. Okay, so if I'm looking at this blue triangle, cosine is still x over r. So that would be root 3 over 2, except this root 3 is negative because of where it is, going to the left. Sine would still be 1 over 2, right? This 1 over this 2. And tangent would just gain a negative sign because of that negative in front of the root 3. So if you look here, back at your chart, and we're filling in our values for 150, make sure you're on the right line. The only thing that changed, or the two things that changed, were cosine and tangent got negative signs. And otherwise, those two lines that we have highlighted are the same because it's from the same triangle, just flipped around. Okay? What's going to happen when we come down to the green triangle? You're right, we're going to keep the same numbers. Okay? What angle was that again? Well, that was 210. Okay? So we're going to have cosine, sine, and tangent for 210. And if we actually think about all-star trig class, which of these should be positive? Tangent, right? Because we're in quadrant 3. These should be negative. Will we get the same values as with the 30 degree, for example? I think so, because it's the same triangle, right? It's just flipped around. So cosine would be negative root 3, if I look at my picture, negative root 3 over 2. Is that the same as what I got for the other triangles? You bet. Okay? Sine, oh, there's a negative on the 1, so when I put it over the 2, I get negative 1/2. And this is going to be positive root 3 over 3. So for this triangle, I had negative cosine, I had negative sine, I had positive tangent. So I'm in quadrant 3. But otherwise, all the numbers match. Do you guys feel like you're seeing this pattern? I'll do it one more time with this last triangle, okay? All right, for this black triangle, I'm looking at cosine and sine and tangent. What did we say was the rotation that got me to this angle? If I go all the way around and then to here, yeah, it's 30 degrees less than all the way around. So that's 330 degrees. So really what I'm doing now is finding cosine, sine, and tangent of 330. All right, cosine is adjacent over hypotenuse. So the adjacent side here is this radical 3. I'm putting dots around. And the hypotenuse is this. So I'd have root 3 over 2. The sine would be opposite over hypotenuse. So that's the negative 1, that's black, over 2. And then tangent is also going to have a negative sign because I have negative 1. So negative 1 over root 3, when I rationalize it, will be negative root 3 over 3. So if I come back to the chart, again, it's the same numbers as the other highlighted lines, except cosine here is positive, and the other two values are negative. Okay, so what I tried to do in just doing these particular lines together is to show you a pattern. All of the relatives of 30 degrees have the same numbers. What do you think this is for? Well, if you guessed that it's going to be for 60 or 45, you're absolutely correct. So flip ahead, and now you can use the back of the next chart to draw this picture. Give yourself some axes, and we'll start over here with drawing a 60-degree angle. So this is 60 this time. Drop a perpendicular. Okay, now if the 60 is there, that means the 30 is up top here. And so this side is a 1. Okay? The hypotenuse is the 2, and the long leg is radical 3. So now draw and flip the triangles into all 4 quadrants. I'm going to pause and come back when that picture's already done, okay? You draw the picture, and then we'll compare. Okay, so this is not the greatest picture of all time again, but, you know, I keep trying to fix it, and it keeps getting worse, so we're just going to run with it. Okay, so this is a picture representing the bow tie, as I sometimes refer to it in class, for all the possible 60-degree angle relatives. We need to figure out who's in this 60-degree family, okay? So we need to figure out what rotations get us to these various points. Well, if I just look at this first one, obviously that's 60. If I were to rotate past this to the green triangle, that would be 180, but not quite because I have this 60-degree in the green section left over. So that would be 120. If I were to keep going into the red triangle, I would have passed 180 and done an additional 60 degrees past that. So 180 plus 60 is what you would need to think of. What is that? It's 240. And then if you go all the way around to here, that's like a full rotation, except you have that black triangle section left over. So what would that be? It's not quite 360. It's 60 degrees less than that, so that's 300. So these 4 numbers are the relatives of the 60-degree family. Okay, so on the second chart, not the same chart that you wrote on before, okay? On a new chart, I would like you to mark down those relatives, okay? I'm going to use a highlighter. You could use a highlighter, or you could use just a star or something, okay? But I'm going to highlight those relatives. So the 60 was in this family, and the 120, and the 240, and the 300. Okay, these are the relatives, or some of the relatives, of the 60-degree triangle. Now, if we look back here, we're going to try to do the same sort of process as with the 30-degree, but I'm going to speed it along a little bit because you've seen it once now. It's very similar. Take the blue triangle, for instance, okay? Let's figure out this cosine and the sine and the tangent for it. Cosine is adjacent over hypotenuse, or you could think of it as x over r. That's 1/2. Sine is y over r, or opposite over hypotenuse. That's √3/2. I'm looking right now at this blue triangle, okay? So the blue writing here goes with the blue triangle. Tangent is opposite over adjacent, or you could think of it as y over x. Either way, you get radical 3. So if we put these into our chart, we should be all set with cosine. Now pay attention to your headings because it's just every other. Cosine and sine and tangent. All right. Now we're going to maybe I should approach this with you just by thinking about what quadrant you're in. 120. Look at your picture. What quadrant is 120 in? It's in the second quadrant. It's the green triangle on my picture, okay? So if we were to think about all-star trig class, in second quadrant, we have sine that is positive. So if I come back here, I know that sine should be positive for my green triangle, and the other two should be negative. And I know that since these are in the same families, the numbers will match. Oh, well, that's a lot easier to do than to just go back to the triangle and have to do TOA again. I bet we know what the angles will be, or what the values will be for the red triangle now. The red triangle is a relative of these other two. So I know I could just copy down 1/2 √3/2 radical 3. It's the same numbers as up above because it's the same family. But now if I think about all-star trig class, T, that means tangent is positive. So tangent's positive, but these other guys have to be negative because it's quadrant 3. Oh, this is a lot easier. Okay, so in quadrant 4, cosine has to be positive. Cosine has to be positive for that quadrant. So cosine was this guy. So that's positive, but these two values, the same numbers, just changing the sign. Those two values have to be negative. Oh, that went a lot faster that time. We should do that for our last example. Our last example is the 45, 45, 90. So we're going to draw, and you could do this on the back of the third chart that you have. You should draw a bow tie for the 45, 45, 90 guy. All right, so here's 1, 1, and radical 2. This will be -1 because it's going to the left, 1, radical 2. -1, -1 because that's going left and down, radical 2. And this one's going to the right and then down, so this would be -1 here, and then radical 2. Okay, so here's our 45, 45, 90 bow tie. Let's think about what these angles would be. This is 45. But if I come all the way to here, and this interior angle in here is 45, let's see, that would be 180, but not 45. So 180 minus 45. What is that? 135, right? If I go all the way around to here, that's like 180 plus 45. Oh, that would be 225. And if I go all the way around to here, that's like 360, but 45 is left over right there. So 360 minus 45, that's 315. So on this chart, I'm going to highlight just those guys, just those relatives, okay? Make sure you're on the same lines as me, because if you write stuff in the wrong line, it's going to be really confusing to you later on, okay? This is 45, so find your line that says 45, okay? Further down the chart, because remember I cut off some of mine. 135. You guys wondering about this stuff out to the left? That's for later in class, okay? So just ignore that for the time being too, okay? 225. Yeah, it'd be really bad if I taught you this whole chart in one day. That would be mind-boggling. And 315. Okay, so those are the four that we just saw were related to 45 degrees. Notice on the chart how they're equally spaced. That's because everything here is a 45-degree section, right? This is 45, this is 45, this is 45, this is 45, right? Whereas with the other pictures, they weren't equal in spacing, right? This is, I'm going to go back to this guy. Right? This is 30, and then you have this big chunk that's 120 degrees. So the lines on that chart that we were highlighting were not equally spaced because the jumps weren't equally spaced. I just thought I'd point that out. Not really important. Okay, let's figure out cosine, sine, and tangent for this. Excuse me. All right, so let's look at this triangle that I'm coloring in right now. Cosine, sine, tangent. 45 degrees. Cosine is adjacent over hypotenuse. So adjacent over hypotenuse would be 1 over root 2. But when we rationalize that, we get root 2 over 2. Sine. Sine is also 1 over root 2. So that's also going to be, when we rationalize it, root 2 over 2. And tangent. Tangent's my favorite. Tangent of 45. Opposite over adjacent, 1 over 1. Ha ha, that's 1. Okay, so we need to put these values into our chart. Notice what your headings are. Okay, pay attention to that. And we've got root 2 over 2, root 2 over 2, and a 1. Let's use that All-Star Trig class shortcut again. Actually, you know what? Right now, we already know we can fill in these. They're all going to match. That's what we saw. We have the same triangle just flipped around, so these values are going to be the same. All that's going to be different is positive versus negative. Awesome. Okay, so we're not quite done because we need to put in the signs. 135. 135 is this one over here. Okay? In that quadrant, all star. Sign needs to be positive. So in this row, sign needs to be positive, but the others would have to be negative. So that's what I'll fill in. Okay, now come back here. Okay, now I'm going to rotate into the third quadrant. This is 225 now. And if I go all-star trig, that means tangent. Tangent's positive. So in this quadrant, this 1 would be positive. These first two entries would be negative for 225. And 315. Okay, 315 is this last guy, All-Star Trig class, C. C means cosine. Cosine's positive. So for the last one here, cosine is positive, and these two guys are negative. Ha ha! And you know what? We are done. There is another chart here where you could compile all of the information on the previous charts into one. But I think we'll talk about that maybe tomorrow during class time, okay? This has been kind of a long video, so I'll let you sign off for tonight and be ready to rock and roll tomorrow. Thanks.